Alright, next we're going to go over the whole limitations section. So I went over this before in, I believe, last week's video, but I realized doing this window capture method would probably be a lot more helpful to a lot of people out there than just doing the whiteboard. So, giving that a try this week. So they've got general information about what the section is for. So we've got the color code for the instrument markings. Red is the operating limit line. Red crosshatch is the power off velocity that you never can exceed. Yellow, special operating ranges. Green, normal operating ranges. So we've got airspeed limits here. So I believe I explained this all pretty well in my last video. But as the helicopter is loaded to a higher gross weight, the knots indicate airspeed, as shown here, is required to be reduced. Got a little note here saying that for VNE reductions with altitude and temperature, so as the altitude and temperature increase, the maximum speed that the helicopter can fly decreases because of dropping air density and aerodynamic reasons that interact with that reduced density. Alright, so additional airspeed limits. So an interesting one is this 100 knots maximum power above maximum continuous power. Sorry. So an interesting one here is under the additional airspeed limits. It's 100 knots indicate airspeed maximum at power above maximum continuous pressure. So I had to look this one up myself. So apparently when you're flying above 100 knots airspeed at a very high power setting, it increases the pitch angle of the blades, and what that means is that if you were to have an engine failure, you would likely have a blade stall, especially the retreating blade stall, very quickly, perhaps before you could react and lower the collective. Another reason is that it stresses the rotor mass and other components of the aircraft to be moving at higher speeds, especially above 100 knots with those high pitch angles. 100 knots airspeed with any combination of cabin doors removed. I explained that last time, but it's basically to avoid people sticking items or body parts outside the helicopter and causing injury. Alright, now rotor speed limits. So, for whatever reason, Robinson decided that the tachometer reading, the normal tachometer reading, should not be 100% when it's operating 100% operating RPM. I have no idea why that is, but they decided that normal operating range should be 101 to 102% rotor RPM. Seems a little bit silly to me. And that correlates in terms of actual RPM to 404 to 408. So power off RPM, we've got the minimum and maximum here. So this would be used during auto rotation. You can have as low as 90% or as high as 108%. There's a little notation here. I'll let you know that transient operations below 101% are permitted for emergency procedures training. So what they mean by that is practicing low RPM recovery and to demonstrate to the student what the low RPM warning horn sounds like. Alright, now you've got some power plant limitations. You got maximum engine speed. If you were to exceed that, I'm assuming it could probably cause some crushing and some stretching damage. Maximum cylinder head temperature. That's there because if you exceed that by very much, you're going to have some warping. Oil maximum temperature. Start frying your oil if it goes much above that. Oil pressure, you've got a minimum and a maximum for both startup and for flight. And that is a bit different because during flight they're assuming that you're going to have a sustained sustained oil pressure at that level. So that is why there's a much narrower band from only 55 to 95 versus from 25 psi to 115 psi. So they give a lot more allowance for startup and warm-up periods because it's not going to be going on for very long. We have the oil quantity minimum for takeoff is 7 quarts. So in my experience, even though 7 quarts is the minimum, realistically that's kind of the maximum amount that you probably want to fill the engine prior to takeoff. So if you fill it much above 7 quarts, it tends to just blow off anything above that level. So there's really not much of a point. However, legally you do need to have at least 7 quarts in there to take off. Alright, so we got the weight limits for the helicopter. We've got maximum gross weight, 2,500 pounds. So I think that's primarily there because of potential structural damage to the frame and other parts. Minimum gross weight, the reason for that is to maintain a minimum acceptable rotor RPM in case of an engine failure. Because if the helicopter is loaded too lightly, you won't have enough weight to maintain the rotor RPM. Or rather, you won't have enough upward flow of air through the rotor system at any given time to maintain RPM. We have the maximum per seat weight, which includes the baggage compartment, 300 pounds. So the reason for that is each seat has a safety feature, which is basically this segment of very light metal around the edge. It's basically like a collapsible foundation that the seat is sitting on. And if you are much over that weight, it may not protect the pilot and passengers as well as it was designed to be, as well as it was designed to. All right, center of gravity limits. So here's a little note that they've left for us. With all the doors removed, a solo pilot weight of 150 pounds or greater will ensure that the center of gravity is within limits. For any weight below 150 pounds, you are required to compute the weight and balance, and removable ballast may be required to obtain center of gravity at forward of aft limits. Refer us to the loading graph for this. So here on the left we have our gross weight of the aircraft in pounds. We have our gross weight of aircraft in kilograms. So off to the left of the screen is towards the front of the helicopter. Off to the right is towards the tail of the helicopter. Look at the top of the graph here. It shows you in inches from the reference datum. And if you remember what I was just mentioning, the reference datum is 100 inches forward of the rotor mast. So the higher the number gets, the further aft or the further back in the helicopter that point is. Got another little handy tag here with the description: most forward weight and balance, or most forward center of gravity with full fuel to keep center of gravity within limits at zero fuel. So if you're loading up with full fuel and the center of gravity goes forward of that, then you automatically know that's going to be out of weight and balance if you run yourself entirely out of fuel. So generally you don't want to go forward at that point if you're going to run yourself too low. Alright, next we have the lateral weight and balance. So on this one, this line down the middle of this figure here is the CL, or center line. Again, the nose of the helicopter would be off to the left, the tail would be off to the right. L means to the left of center, R means to the right of center. And if you're doing a weight and balance calculation, anything off to the right is considered a positive loading, and anything off to the left would be considered a negative. And again, down here, you basically have a scale showing you how far back from the reference datum you are. In this case, they're calling it the station, and it's in centimeters from the reference data.